This video is on quadratics review. We're going to be converting quadratics between forms. For quadratics, there are three forms. We have standard form, which is y equals ax squared plus bx plus c. Standard form is when you have no parentheses and you have your highest exponent, which your degree is 2, and it goes in order from your highest exponent to your lowest. Standard form will automatically give you your y-intercept of your parabola, which is going to be that 0, c value. You will also look at intercept form, which is y equals a parentheses x minus m parentheses parentheses x minus n close parentheses. It might also look like y equals a parentheses x minus p and x minus q. Either one of these mean the same. Another name for intercept form is called factored form because what you are doing is factoring the standard form to get to intercept form. Intercept form will give you the x-intercepts of the parabola. Not all quadratics are factorable. Therefore, not all quadratics will have actual x-intercepts that you can see. So the x-intercepts will be when you plug the parenthesis set, whatever has the x into it, equal to 0 into the zero product property. So we would set the factors equal to 0 and solve. So this would be x minus m equals 0. Our x-intercept would be at m, 0, and then n, 0. The last form we're going to be looking at is vertex form. Vertex form is y equals a parentheses x minus h parentheses squared plus k. You get to vertex form by completing the square on standard form to get it into vertex form. Vertex form will give you your vertex of the parabola. The vertex of the parabola will come from the h value and the k value. The h value is just like if we were to use intercept form. We would set the inside of the parentheses equal to 0 and solve for x. So we will generally end up changing the sign on whatever is inside of it, change the h, but we will keep that k value for the y of our vertex. So again, these three forms give you the four major coordinates of a parabola: the y-intercept, the x-intercepts, and the vertex. Again, not every quadratic is factorable, so you won't always be able to easily find the x-intercepts. But every quadratic has to have a y-intercept, so we can always put it into standard form, and every quadratic has to have a vertex, so we can always put it into vertex form. We have 4 examples on here, and we're going to be converting them. The first example is already given to you in intercept form. Intercept form, we want to go to standard form, then go from standard form to vertex form. So to go from intercept form to standard form, we want to distribute. If we're going to distribute, I'm going to put the original problem of, I'm going to leave off the y for right now. I'm going to put -2 parentheses x minus 4 parentheses parentheses x plus 3 parentheses. We're going to distribute the set of parentheses first, so I'm going to have -2. I'm going to keep one set of parentheses because we're going to go from 2 sets to 1 to 0 sets. I'm going to distribute the x times x is x squared. X times 3 is positive 3x. Then I have that -4 times x is -4x. And then -4 times 3 is -12. And then I can close my parentheses. I can simplify the inside of this. So I have -2 parentheses x squared. And that becomes -x minus 12. And then I can distribute that -2 to everything. so I can get rid of all the parentheses. So we'll have negative 2x squared. Then negative 2 times negative x is positive 2x. And then negative 2 times negative 12 is positive 24. This has no parentheses. It is an exponent from the highest to the lowest. This is in standard form. So our standard form of this equation would be y equals negative 2x squared plus 2x plus 24. Now to go from standard form to vertex form is when we have to use completing the square. Completing the square. Now this can get a little tricky because of the numbers. There is another way of putting it into vertex form, which I will show in just a moment. So I'm going to take the standard form equation of y equals negative 2x squared plus 2x plus 24. So to complete the square on here to get it into vertex form, we're going to move the constant value to the other side because I want to get my perfect square trinomial so it'll factor to a perfect square. I need to create a perfect square trinomial. This is not a perfect square trinomial, so that's why we're creating that. I'm going to subtract this 24 over to where the y is to get it away from it. So I'm going to have that y minus 24 equals. Now, because I'm only going to have these two parts here, I want my x to be a 1 inside. So what that means is this negative 2 on this x squared, I actually want to factor out of just these two parts. So I'm going to have that negative 2 on the outside. Now I'm going to have, since I'm dividing these two parts by negative 2, I'll have a positive x squared. And then I'm going to have that 2x divided by that negative 2 will give me that negative 1x. Now is when we create that perfect square trinomial. To create a perfect square trinomial, I have to take that half of b and I have to square it. So my b value right now is negative 1. I'm going to take half of that and then I'm going to square it. So half of b squared will give me a negative 1 over 2 times negative 1 over 2, which is a positive 1 over 4. That will give me that perfect square trinomial. So I will have that negative 2 parentheses x squared minus 1x plus that 1/4. That is a perfect square trinomial, so it'll factor to be something that looks like this. Now, since I put that positive 1/4 on the right-hand side, I have to put something on the left-hand side as well. I already have that y minus 24 still, so I have to add something over here. I cannot just add the 1/4 because that 1/4 is actually multiplied by that negative 2. So I have to multiply this 1/4 by that negative 2 when I want to put it over here. So a 1/4 times a negative 2 is going to be a negative 1/2. So I'm going to add a negative 1/2. So what we will end up having, we're going to have that y minus negative 24 and minus 1/2 is, I'm going to put that as a decimal for right now. It's going to be minus 24 and 1/2 because it's just negative 24 and negative 1/2 together is negative 24 and 1/2 is equal to, I still have that negative 2, but since we've created a perfect square trinomial, we can factor this by taking the square root of the first term and the square root of the third term. The square root of x squared is x. The square root of 1/4 is, if I take square root of 1, take square root of 4, becomes a 1 over 2. Now I need my sign in here. This is either going to be a positive or negative. It all depends on this middle sign. Since I took the square root of the first, square root of the third, I have to do something with the second. I just focus on the sign of the second. So that's a negative, so I'm going to have a minus 1/2, and then I'm going to have that squared, because it is a perfect square trinomial. The last part is to get it back into y equals, so I'm just going to have to add that 24.5 over. So I can go ahead and put in vertex form y equals that -2 parentheses x minus the 1/2 parentheses squared. Now we're going to have that last part over here. That's that 24.5. I have to add that to the other side. I'm going to have a positive 24.5. And that is vertex form. Now I do want to show you another way of looking at that real quick. What in here is different is the A, the H, and the K. Every single one of these forms has an X and a Y. So we have to look for the similarities and differences. They all have an X and a Y, but they also all have an A. So the A for all of these, -2, -2, and also -2. My A was -2. I need to find my H and K, which is the vertex. So I can actually use my calculator to find the vertex. So if I take my original function, since I know that is correct, I'm going to go to my y equals. I'm going to graph this. I'm going to type in -2 parentheses x minus 4 parentheses x plus 3 parentheses. I'm going to go to zoom standard for right now because that'll give me the 10 by 10, so 10 to the right, 10 up, 10 left, 10 down. Go to zoom standard, see if I can find my vertex. Now, I can see that it's opening down. I can't see my vertex, but I can go to zoom. I can go to out. I'm going to press enter on that, but notice that nothing happened. So I have to actually press enter on the graph for it to zoom out. I'm going to press enter, and now I can see the vertex. I can't find the exact location by looking at it, but I can see it. We can go to calculate, so I'm going to press the second button, calculate. I want to find the vertex, which is either the minimum or maximum. This was a maximum, so I'm going to go down to maximum. It says go left bound. I want to go to the left of my vertex. I'm going to press the left arrow key, and this is definitely on the left side of that vertex, so I'm going to press enter. Now it tells me to go right bound, so I'm going to press the right arrow key until I'm on the right side of the vertex. I'm on the right hand side. Press enter. I don't want to guess to determine what the vertex is. I just want it to tell me, so I'm going to just press enter right now. And then it will tell me our vertex. Our vertex, it says this is x equals 0.49999. So this is 0.5. So it's a half, which is what we said it would be. And then at 24.5. Now, if you look at our equation, we have a -1/2 in here. But remember, we would set this equal to 0 and solve. So we would change this sign. So this would be a +1/2 for the actual coordinate. And that is a +1/2. We keep the sign of the k, which is a +24.5, and that is a +24.5. So I could automatically have written my equation by finding my vertex and knowing my a value. On the next example, we're given standard form. We want to find intercept form and vertex form. So keeping it in standard form, in order to find, standard form, we're going to factor to find the intercept form. So to factor, the first thing you look for is your GCF. The smallest number is 2 on here, so the only number that can go into all three of these is a 1. And then we look for letters. All three of these do not share a letter, so our GCF is just 1. We want to put it 2 sets of parentheses. Now, you can factor any way you want to. I'm going to use the method of guess and check so I can do it quickly. I want to know what the factors of 2x squared are, which is just 1x and 2x, so those have to be in the front. 1x times 2x will give me my 2x squared. Just like when we were distributing to get the standard form, we're undistributing basically. I know that 1x times 2x, if I were to distribute that, I would get back to my first term. So I need to know if the last thing I distributed was that the 2 numbers, so that was at -4 times that 3, which is what gave me the -12. I need to know what two numbers would give me that negative 30. So I'm going to write out my list of the numbers that will give me 30. I know it's 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. Now this is that guess and check method. I'm not going to focus on the signs right now. I just want to plug these into here. These are all possible values that can go on the back. I will say one thing, that no even number can go in with the 2 because it already is even. No common factors can go in with each other. This 6 cannot go with the 2, but the 6 could go with the 1. So I'm going to put the 6 in with the 1 first, and then the 5 with the 2. Now I know when I distribute, I'll get 1x times 2x will definitely give me my 2x squared. My 6 times my 5 will give me the 30. I don't know the sign yet, but I know that 6 times 5 will give me 30. When we distribute, what we have to change is when we multiply the number times the letter, and then we combine those two to get our middle term. So if I multiply my number my letter times my number, and my number times my letter, those two things will have to combine. So 6 times 2x is 12x, and then 1x times 5 is 5x. Now we want to see if these can combine in any way to give us that negative 7. So if we do 5 minus 12, that will give us our negative 7. So if we have a positive 5 and a negative 12, we need to make one of these negative and one of these positive. To get a negative 12, the 2 and the 6 will give us the 12. Well, that 2 has to stay as it is. So the 6 can become a negative because that's the number that can have a sign on it. The 5 and the 1 have to both be positive to give us that positive 5. So if I look at these numbers, that 6 was the negative and the 5 was the positive. So to recheck this, I know that x times 2x gives us 2x squared. Negative 6 times 5 will give us a negative 30. And then negative 12x and positive 5x will give us a negative 7x. That means that this is factored. This is actually in factored form. So we can write out that y is equal to parentheses, that x minus 6, and that 2x plus 5. Now we can go from standard form into vertex form by completing the square, or just finding the vertex from the calculator and using your a value. So let's actually do that. Let's find our vertex from the calculator. So vertex from the calculator. So I'm going to go to my calculator. And I'm going to type in the original equation because that's the one that we know for a fact is correct. So I'm going to go to my y equals, type in 2x squared minus 7x minus 30. I'm again going to go to Zoom Standard and see a graph. So I can see the graph, but I cannot see the vertex. So I need to zoom out. Now again, I have to press enter on the graph to make it zoom out. And I can see the vertex is down here. I can't actually find it by looking at it, but I can find it by calculating it. So I'm going to go to second, calculate, and I wanted the minimum this time because this one is opening up. So it says go to the left of the vertex. I'm going to press the left arrow key, and my vertex is down here, so I know this is to the left. I'm going to press enter. Now it says right bound. I'm going to go to the right-hand side. I'm on the right of the vertex, so I can press enter. I don't want to guess, so I'm just going to press enter. It's going to tell us our vertex is at 1 and 75/100 and negative 36.125. So I'm going to write that out. Our vertex from our calculator was at 1 and 75/100, comma, negative 36.125. But we also, for our vertex form, we want our vertex, the h and the k, but we also need that a. Now from the original, our a value was 2. So I'm just going to put a value is equal to 2. We have those three pieces of information, so we can put it into vertex form. Y equals. It's y equals a, so the a value is 2, parentheses, we're going to have x. Then we have to change, if you remember, change the h, so our 1.75 is our h. That we're going to put it in here as a minus 1.75, parentheses, squared, because I'm following it from vertex form. And we're going to keep whatever the sign is for our y. So our y is negative 36.125, so minus 36.125. This is vertex form. A little bit easier than having to do all of this to get our vertex. The next two examples are we're given vertex form and we have to put it into standard form and to intercept form. You want to actually put it into standard form first by distributing. So for part C, we're going to distribute. We're going to write down the original equation for part C, which was that parentheses x minus 5 parentheses squared minus 4. X minus 5 squared really means x minus 5 times x minus 5, then minus 4. We're going to distribute the parentheses, x times x times negative 5 times x, and negative 5 times negative 5. We're still going to have one set of parentheses from 2 down to 1. So x times x is x squared. Then we have negative 5x, and then positive 25. And then on the outside, we still have that minus 4. There is nothing on the outside to distribute into the parentheses except for a 1. So 1 times all of this will get rid of the parentheses, but we can also combine some stuff. So we'll have 1 times x squared is x squared, but we have negative 5x and negative 5x. That is a negative 10x. And then we'll have that 1 times 25 is plus 25. So the parentheses are gone, but we still have that minus 4 here. So we want to combine our like terms here. So our standard form will be y equals x squared minus 10x plus 25 minus 4 is 21. That is standard form. And now we can go to intercept form by factoring. So factor, first thing you look for is GCF. Our smallest number is a 1 right here, so our GCF has to be a 1. And then we look for letters. All three of these do not have a letter, so we cannot pull out a letter. So we're going to go to 2 sets of parentheses. We want to figure out what multiplies to x squared for the front. So x times x are the only things that multiply to x squared, so we have x times x. Then we need to figure out what multiplies to 21. So I'm going to list out my factors of 21, which are 1 and 21 and 3 and 7. So I'm going to put the 3 into this first set and the 7 into the second set. So we know that 3 times 7 will give us that 21, but we need to figure out what will combine, like we did here, to combine in the middle to give us that negative 10. Now, we're not having the negative 5 in here because we ended up changing that last term. So we need to end up figuring out what multiplies the outer and the inners to give us that middle term. That's why we multiply the number and the letter, and then the number and the letter, and determine, can the 3 and the 7 give us a negative 10? If they're both negative, they can give us that negative 10. So if I make here 3 and x have to give me a negative 3, so I have to have a negative 3 here. And the x and 7 have to give me a negative 7x, so I can have my 7 as negative. So if I come over here, I'll put my negative 3 and negative 7. Negative 3 times negative 7 gives us still that positive 21, so that still works. And then this combined will give us that negative 10. So this is factored. We can write this in factored form as y equals parentheses x minus 3 and parentheses x minus 7. That is factored. This last example is again in vertex form. We're going to put it into standard form first by distributing. So for standard form, we're going to distribute. we have the original problem of 6 parentheses x plus 1 parentheses squared minus 6. So again, that x plus 1 squared means it's 6 times x plus 1, and then minus 6. We're going to distribute the parentheses first. I'm going to keep the 6 on the outside. We're going to go from 2 sets down to 1. We're going to have x times 1 times x, and 1 times 1. X times x is x squared. And we're going to have 1x and another 1x. So I'm going to go ahead and put this as plus 2x instead of having to write it out like I did up here. Negative 5x gave me the negative 10x. So I'm just going to go ahead and put, that's going to give me a 1x and a 1x. I'm going to get 2x from that. Then a 1 times 1 is plus 1, close parentheses. Then we have that minus 6. Now I have to get rid of the parentheses again, so I have to distribute this 6 to the parentheses only. So I'm going to have 6x squared plus 12x plus 6, but then I have this minus 6 at the end. Now all I have to do is combine our like terms, and it'll be in standard form. So standard form will be y equals 6x squared plus 12x, and then 6 minus 6 is 0, so this is in standard form. Now to put it in intercept form, we factor. So to factor, we always look for our GCF first. So the smallest number is 6. 12 can be divided by 6, so our GCF has a 6 in it. Then we look at our letters. These both actually have an x. The smallest amount of x's is 1x, so I can factor out one of the x's as well. So our GCF is 6x. We put that on the outside of the parentheses, and then we divide everything by that 6x. So 6x squared divided by 6x is just x. And then 12x divided by 6x is just 2. So a positive 2. This is actually in factor form. We can't go any further because we no longer have an x squared. So our factored form is going to be y equals 6x parentheses x plus 2. So to convert, again, in order to convert to standard form, you'll need to distribute. To convert to intercept form, you will need to factor. And to convert to vertex form, you would complete the square, or you would just find the vertex using your calculator and the a from the original equation.